Hi guys, Adam from Heat Geek here. I'm at Caldera, which we'll tell you about in a minute, joined by the CEO, James Macnaghten. Hello, James.
Hello, Adam.
Thank you for having me here. I was here about 2 years ago. You invited me down to have a look at what you were doing, something a bit interesting in the heating space in domestic, and it was very interesting. You were still developing what was there. However, I've returned today and it's a bit different. And before I go into that, what's changed? Can you give us a quick overview of Caldera and what it does and what it is?
So Caldera is all about storing heat, sort of storing energy, but we don't store it like a electrical battery, as in you don't get any electricity out. With our system, put electricity in to heat it, ideally surplus, renewable energy. We're very, very focused. The grid's going to need tons of flexibility as we build more and more wind and we build more and more solar. We need things to smooth all of these out and to balance them. So we're all about storing, taking that surplus and converting it to heat. We store it as heat, and then we can provide heat on demand to factories and to industry. And these are organizations that use, 10,000 times what a home might use, per hour. So we're talking about really big sorts of kit, big power flows. But as you might have hinted, we started at a much smaller level that, we can talk about a little bit more. But now we've gone very focused on industry because it's like a quarter of all energy used is used by industry for heat.
Right.
So it's like this big problem we need to solve. And it's particularly well suited to matching it with solar.
Right.
And that's why we moved into it. And we can talk a little bit more about it. But we originally were very focused on homes.
Amazing, yeah. So when I came, we saw the unit that we've looked at over there, which is essentially like a Dalek-looking type thing,
Good.
which goes out in the garden and it stores heat with an element. Actually,
Pull one out.
use the elements here.
Yeah.
One of these elements, and during times of surplus energy, which could be solar or cheap tariff and or a version of. And then it's a simple heat exchanger that just sucks the heat back out whenever you want heat, right?
Correct.
That's a simple way of kind of describing it.
It's a simple system.
And you've now decided to pivot very bravely, and I would suggest probably, correctly, in my opinion, mainly or solely on industrial. Is that right?
Solely, correct.
And why is that? Why doesn't this potentially work in domestic?
When we started, you could get some really good, cheap off-peak overnight tariffs. So there is a certain type of property with, let's say older fabric, small cast iron radiators, difficult, and by difficult I mean expensive to retrofit with a heat pump. Also, there's the houses with micro-bore piping, which you also know, difficult to retrofit with a heat pump. So we had a solution where and predominantly we're looking at homes, the bigger homes, off gas grid, on oil. And when we started, you could get a very good overnight rate, 4 or 5 hours. The aim was you charged up one of the heat batteries with this cheap electricity, so it's hot, and then it could basically provide the full functionality of a boiler. So lots of power and hot water. So we were quite happy doing 30 kilowatts, 70 degrees C water, do 80. I mean, it makes no difference to our system. Yeah. So that was our focus point. We started, and 2021, we were very good. And then obviously Russia invaded Ukraine. So overnight, electricity became expensive. And funnily enough, oil became a bit more expensive, but really not a lot more. And what we saw was all of these tariffs disappeared because the price of electricity went up. If you even the price cap didn't apply for dual tariffs. So we suddenly went to the point where the original proposition was you could install one of our units, it cost more than the gas and oil boiler, but you saved the money because it was cheaper than oil because you could charge it overnight. And you didn't, a lot of people we would speak to were convinced, whether rightly or not, but were convinced that a heat pump would not be the right solution for their home, or they'd had quotes and the prices were very, very high. So that was our starting. Where we ended up as soon as Russia invaded Ukraine was, it cost more than an oil boiler to install and it cost a lot more to run. And we saw no end in sight. So it wasn't clear to us when that situation would change. The problem with, so ideally we like renewables. So solar is great for producing cheap electricity or cheap energy. But in home heating, you use all your energy in the winter, normally December and January, when the sun doesn't shine. So home heating and solar is a really bad match in that the solar generates all the energy in the summer when you don't need it, and nothing in the winter when you do. Industry is completely different. So industry just uses the same level of heat all year round. So that was an obvious, so we were like, the only place we know we can get it is if we go to a factory and we help them build a big solar farm, and we connect in via what's called a private wire. So it's just like putting it on the roof of your house, but it's big. And you don't even need to export to the grid. So we can just use everything on site for electricity or heat. There was a second reason that we went there, and that industry tends to use heat between sort of slightly hotter temperatures than home, so between 100 and 200 degrees Celsius, often in the form of steam. And even within the domestic space, there's a very clear pressure. We sort of say under 100 to use heat pumps. So whereas when you go above 100, it becomes harder and harder to deliver it with a heat pump,
100
even Celsius.
Yeah, right, yeah.
So when you're above the boiling point of water, but it's like generally heat pumps make the most sense when they have a high COP, coefficient of performance, as I know your viewers will get. So you need to have a high coefficient of performance, and normally that means there's a limit between how hot you can go and how the temperature out, your source temperature, so how much you're lifting it.
Yes.
So, if you're going to 50 or 60 degrees, you can do that very efficiently with an industrial heat pump.
Yeah.
If you're going to 150 degrees and you've only got ambient as your supply, it's very, very hard and it doesn't make sense. So not only did going to industry solve our cheap energy problem, which is we can go for solar and we can just use it when it's generated, it also put us in I think, a stronger position, because one of our concerns, and we've seen it in the UK, is that government is putting a lot of money behind heat pumps. There's a lot of subsidy there, and that makes it harder when you're starting out. If you're competing technology, you can get 7,500 from the government for. So I think it was both I would say the sort of positioning the company in a better position for the future, and also the fact that we got this cheap energy. So we made this decision to pull out of the domestic market. We had a lot of units in homes. Everybody was, I would say without shadow, everyone wanted to keep them, but we didn't want to support them. So we brought them all back. And on the same time, we've been very lucky attracting some funding, and I will say thank you to the Department of Energy Security and Net Zero, DESNZ. They gave us a significant amount of funding to develop our industrial product, and that has been really game changer for us. So
when did that come
very
in?
grateful. That came in, we were told, in April of last year.
Right.
So everything you see here, like the substation and all of this, is all part of that. So we've moved really fast.
That's incredible. Was that a difficult decision to make? To go from, I've set my thing on this for how many years were you with
2.5? We were a couple of years. We were building up to it. So we started the company in 2017. 2019, I think we developed Warmstone, and then it went from there quite quick. No, in fact, it might have been in 2018, 2019. But we were. I think when we went out to raise money in 2021, we'd had my home heated by a unit, and that gave us the funding to go and build the trial units and to put them out.
Did this just feel like a steer though, or did it feel like, right, I'm going to have to swallow something here and change tact, or was it a pull?
I think we were like, I would have people ring up and say, I don't mind if it costs me more, but I want one of your heat batteries. And it'd be going, and I just know that that's not true, because if your bill goes up from 500 a month to 1,500 a month, you do notice, even if you're not wealthy. And I think we just felt it was, we weren't convinced there was a business case, and I think we just we can't sell to people until we know that they can save money. Because my thing is, you have to save money. It's not just about saving carbon. It needs to be better
to scale,
and just generally, we can't afford to subsidise everybody. We have to have solutions where the technology is better and cheaper.
So did you find? So then, did you look for and find the application, or was it kind of obvious at the same time?
No, we'd always known about industry, but it was a big step to say we need to go a lot larger.
Right.
And I think even when we got into it, it wasn't fully clear how much larger we had to go. And as we got further into it and we understood, this is why we're at 3 meters and 7.5 meters high, because that's the size industry needs.
Just changed gear.
We just changed gear, exactly.
Cool.
So it was a big call. I think the team responded really, really well to it. We took quite a big bet on that we would get the funding. It would have been much trickier if we hadn't been able to. So I think that made a big, and that's actually been, there were certain things we needed. We just worked really hard, so we had enough time to get the funding to get where we are today.
That's amazing. What is it? So how does it work? Can you give an overview?
Yeah. So we make sort of like a conductive concrete. We make these big blocks of material out of scrap aluminium and rock, and we take the rocks. They're heated up. we melt some aluminium, which melts at a relatively low temperature. It's much lower temperature than steel, and we pour it over the rocks, and it runs between all the little holes in the rocks, and it sets. And you end up with a block which sometimes looks a bit like a Rocky Road cookie. You know, it's you can see the rocks and you can see the aluminium, and it's got this lovely pattern to it. Two things we do within the block: we put electric elements, so we put little elements like this, and they're embedded, and because the aluminium is so conductive, keeps them relatively cold. You know, they're much. There's almost no difference between the block temperature and these elements. In most applications, the elements are much, much hotter because they only have air around them.
Of course.
And then second thing is we put a little steel pipe inside it, and that's how we get the heat out, by squirting water in. So you end up with a block with electric elements, steel pipe, and aluminium and rock.
Is it, does that mean they last longer if they're kept cooler?
Yes, they last much, much longer.
Right, amazing.
And it means that we can use really low-cost elements. You know, these millions of these are made every day. And that's a big point, because actually, you know, you have to keep the cost of everything down. So using effectively these sort of elements saves us so much money compared to higher temperature elements, which are between about 10 and 100 times more expensive per kilowatt.
Okay, so let me try and do a really quick summary. You're using rock because rock has the most density and is cheap, or has a high density.
No, rock is the same density as the aluminium. It's rock and aluminium, same density, and they store the same amount of heat.
Right.
It's just aluminium is 100 times more conductive than rock. Of course.
Right, so we fill rock up, we fill all of the gaps with aluminium for maximum contact surface area. We charge that with electric, cheaper, cleaner electric heat up to 500 degrees. That's our capping point.
And that's full, always full at that point.
And it turns off. And then we're using water or steam to extract back out to use at point of use.
We're using the boiling process to take the heat out.
Right, okay.
So when the water, you don't need very much water to convert to steam to extract a huge amount of power. So we use that to take it out, and then we cool the blocks down, and we sort of call them in our current, about 250 Celsius, we call them empty. So they're still very hot, but from our perspective, that's empty.
And why a user would have this is because they can save a lot of money potentially on storing when they get these blasts of renewable energy when they potentially don't need it. You can absorb all of that quickly, keep it, and drip feed it into your process.
And it's also because, you know, businesses are under a lot of pressure to hit net zero. They've got their scope 1, their scope 2, and, you know, these factory managers are looking, going, you know, I can't stop the production line. You know, we need to run it. Has to run. You know, I can't stop it to fit. You know, to do a new system or to fit this. But actually, ours is a plug-in sort of play, which is they'll have 5 big, giant boilers, the size, each one the size of a sort of, you know, a bus, and you basically go, and we'll plug in alongside it, and they can just turn one of them off, or 2 of them off, or 3 of them off. And it's very much a transition. We're not trying to take people on day one from all gas to, you know, all zero. I think it's a transition. What we want to do is we want to take 25 or 50% of their gas away, and we want to do it to save them money. So the key point is we don't want them to pay any more than they would have paid if they kept running gas. It's just a fuel substitution.
And ultimately, you're helping the grid even out its spikes, which really helps the net zero kind of agenda. So you're hitting sort of 2 areas there.
Absolutely.
In one go.
And the grid congestion, and again, this is why we build the solar farm connected to the factory. Pretty much everywhere in the world, we've got renewables. The grid is getting congested. And even when you work out everything we need to do uncongest there's still going to be more and more renewables going on. So we see grid congestion being an ongoing problem for a long time. And again, why putting renewables in connected directly to these big load centres behind the meter just works. The economics so much better.
One last very quick technical question. What's the reason for the capping at 500 degrees? Is that?
Everything gets expensive above 500 degrees. So steels, you need higher quality steels. Things start to creep. We've had it from day one, and it's just, as soon as you get to 550, now I need to sort of have a higher grade this and a higher grade that, and suddenly you start to put cost back into the system. And this is one of the things we say, which is high temperatures, to our view, only give you high cost. There is a sort of medium temperature range, which is actually the cheapest sweet spot. And by setting ourselves at 500, we've had no problems. Everything lasts, the elements last, the coils last, it's great.
James, I've had an amazing day here today. What you're doing is incredible. Amazing pivot and a brave business decision as well, going to and focusing on what you're doing. and an impressive individual. Thanks very much for having me, and I wish you all the best of luck.
Thank you for coming, Adam.
Cheers. That's it, guys. Like, subscribe, and I'll see you on the next one.